Welcome to tonight's video on horizontal vertical transformations and basically all types of transformations on the 6 basic functions. The first type of transformations we're going to talk about are what are called horizontal shifts. Horizontal shifts occur when you're adding and subtracting inside the function. So here, notice we're subtracting 3, which means in reality, like if you look, what number would make this equal to 0? It would be positive 3. So that means we're going to go to the right 3. So if you take the base function here, which is f of x equals x to the third, the transformation is going to be a horizontal shift to the right 3 units. So if you make a table here with your original points, remember for this function it's -2, -8, -1, -1, 0, 0, 1, 1, and 2, 8. And then you add 3 to each x coordinate because you're going to the right. So notice adding 3 to -2 gets you positive 1. And then adding 3 there gives you positive 2. Adding 3 here gives you 3, 0. Adding 3 gives you 4, 1. And adding 3 gives you 5, 8. So if you notice, it's now at 1, -8. 2, -1. 3, 0, 4, 1, and 5, 8. So this is your new graph. The original function, f of x equals x to the third, was here. That was the original. So notice everything shifted to the right 3. So horizontal shifts go as follows. If you have f of x minus c, it's a horizontal shift on f of x to the right c units. If it's f of x plus c, it's a horizontal shift on f of x to the left c. So when it's to the right, that means you're going to add c to the x coordinates. When it's to the left, you're going to subtract c to the x coordinates. So you notice how when it moved to the right, I added that number to each x to move it to the right 3 units. Next, we have vertical shifts. And the vertical shifts, if the number is added outside of the function, it's a vertical shift up c units. So each y coordinate would be added to c. If it's f of x and then minus c, that's a vertical shift down c units. And that means you subtract c from each y coordinate. So here, if you notice, the base function is f of x equals x squared. Remember, our original points are 2, 4, 1, 1, 0, 0, negative 2, 4, negative 1, 1. So it looks like this. There's our original function. In the correct order, we always go horizontal first and then vertical. So there's a horizontal shift here. And since it's minus, it's to the right 3 units. So we're going to take each x and add 3 to it. And then the plus 3 here means there's a vertical shift up 3 units. So we're going to take each y and add 3. So we're going to make a chart, kind of like we did in number 1. We're listing the original points. Zero, 0, 1, 1, 2, 4. And then our chart is x plus 3 and y plus 3. So when we do that, we're adding 3, so we get 1, 4. Adding 3 to the x, negative 2 plus 3 is 1. And then adding 3 to the y gives me 1, 7. So that's the new point. Adding 3 to the x is 2. Adding 3 to the y is 4. Adding 3 to the x is 3. Adding 3 to the y is 3 as well. Adding 3 is 4. Adding 3 is also 4. And then adding 3 is 5. And then adding 3 is 7. So those are the new points shifted right 3 and up 3. So 1, 7, 2, 4, 3, 3, 4, 4, 5, 7. And there's your new graph. F of x equals x minus 3 squared plus 3. Reflections. There are 2 types of reflections. About the y-axis. That's when you basically have f of x equals f of negative x, meaning the negative sign is inside the function. That means it's negative x. And then f of x equals the opposite of f of x. That's where the negative sign is outside the function. That is negative y. So for example here, if you look at this, the base function here is f of x equals the square root of x. Base function is square root of x. So remember, the original points are 0, 0, 1, 1, 4, 2, and 9, 3 for the square root function. The graph looks like this: 1, 1, 4, 2, 9, 3. That's the original graph. Now, the transformations in the correct order of the transformations here. The first one is a horizontal shift left 2 units. It's x minus 2. Now you're multiplying by a negative sign outside, so now there's a reflection across the y-axis, or sorry, the x-axis, because you're multiplying outside. So that's going to be negative y. And then there's a vertical shift down 6. So it's going to be y minus 6. So when you make a table here, there's going to be 3 columns. You're going to have x minus 2, because you're going left 2, negative y, and then y minus 6 on these coordinates. So when I take x minus 2, so I get negative 2, then the opposite y, well, opposite of 0 is still 0, minus 6, so negative 2, negative 6 is our first point. 1 minus 2 is negative 1. Opposite of y is still negative 1. And then minus 6 is negative 7. 4 minus 2 is 2. Opposite of 2 and the y is negative 2. Minus 6 is negative 8. And then 9 minus 2 is 7. Negative 3 opposite is, 3 opposite is negative 3. And then minus 6 is negative 9. So those are your new points that you are going to graph. So you graph negative 2, negative 6, and then negative 1, negative 7, 2, negative 8, and 7, negative 9. And there's your new graph. All right, so the correct order of transformations at this point, you have a horizontal shift. That would be first, if there's a horizontal shift. Then you're going to talk about reflection across the y-axis. That would be done second. A vertical stretch or shrink will be done third, and we'll talk about that in a second. And then fourth is a vertical shift up or down. So the only one we haven't talked about is the vertical stretch or shrink, and that's what we're getting to next with these absolute value functions. All right, so f of x equals 3 times the absolute value of x. So think about it this way. If you had x and y, and you put in numbers for x, like negative 2, negative 1, 0, 1, and 2, well, your numbers for y would be 3 times bigger than they normally would be. Because normally, if you're talking about the absolute value of x, when you put in x and y, you get negative 2, 2, negative 1, 1, 0, 0, 1, 1, 2, 2. But now if you multiply by 3, now your y values go up by a factor of 3 on the graph. So that means the graph is going up vertically 3, 2, 6 is going up vertically faster. So this is what's called a vertical stretch. So if I say f of x equals a times f of x, or in this case y, equals a times f of x, meaning some number times the function, it is a vertical stretch if a is greater than 0, like if you're multiplying by 3. But if you were multiplied by a fraction less than 1, like 1/3, it would shrink these y values. So it's considered a vertical shrink if a is between 0 and 1. If it's a fraction between 0 and 1, it's considered a vertical shrink. Now over here, if you multiply by 3 inside, that's going to affect the x values. That means to get the same y that you would have started with f of x equals x, you don't have to put as much in. Like here, I would only have to put in negative 2/3. Here I'd have to put in negative 1/3. Here 0, here 1/3, and here 2/3. Because when I multiply 3 times negative 2/3, I get negative 2, take the absolute value, and I get 2. So any number in here that is a number bigger than 1 is going to give me a horizontal shrink. And that is when y equals f of a times x, and a is greater than 1. It's a vertical stretch, sorry, if a is greater than 1. It's a horizontal stretch if a is between 0 and 1. Let's say I said f of x equals 1/3, absolute value 1/3 x. Now, to get those same y values, notice I now have to put in 3 times as much. I'd have to put in negative 6. Or sorry, 2, 1, 2. I'd have to put negative 6. I'd have to put in negative 3, 0, 3, 6. So notice it stretches. I have to put in more when that number is a fraction, if it's horizontal. All right, so here's the correct order transformations I talked about, and these two are interchangeable. I know in the beginning I said you could do a reflection first. Those two, the order doesn't matter as much as these two it does. So horizontal shift has to be first and vertical shift has to be last. You can switch these two in any order. All right, so let's try a couple and see what's going on. The base function here is f of x equals the square root of x. And those original points are 0, 0, 1, 1, 4, 2, 9, 3. So those are your original points and the graph. Now, if there is a horizontal stretch or shrink, which there is because it's inside, you're going to factor it out. So you know how you have 1 minus 2 times 9 times the square root of x. Well, remember, the square root property allows you to break it up into the square root of 9 times the square root of x. And what is the square root of 9? it is 3. So this is 1 minus 6 rad x. Or, another way to say it is negative 6 rad x plus 1. If you look at the transformations, there is no horizontal shift because there's nothing done inside the square root. There is a reflection across the x-axis because you have negative y. Then there is also a vertical stretch by 6 because you're multiplying by 6. And then there's also a vertical shift up 1. So that means you're going to take y plus 1. So when you make your table, you have negative y, y or 6y, and then you have y plus 1. So when you graph it, you have 0, 0. 6 times 0 is still 0, and then plus 1 on the y gives you 1. Negative 1 for the y, and then negative 6, and then plus 1 gives you negative 5. Negative 2 times 6 is negative 12, plus 1 is negative 11. And then negative 3 times 6 is negative 18, plus 1 is negative 17. So here, if we make this go by 2's, we have 0, 1, which is like right there. We have 1, 5. Here, I'm just going to make this bigger because it's a little small. So I would just put 0, 1. Then I have 1, negative 5, which is down here. Then I have 4, negative 11, which would be down here. And then I have 9, negative 17, which would be way down there. So this graph looks like that. All right, the last one. So this base function is f of x equals x squared. So remember the original points are negative 2, 4, negative 1, 1, 0, 0, 1, 1, and 2, 4. When you graph the original graph, it looks something like this. It's a parabola. Now, if you notice, there is a number multiplied inside here. It's a 3. Before I take it out, we have negative 3 here times x minus 4 in parentheses squared. So what I'm going to do is I'm going to say this is negative 3 squared times x minus 4 squared. So in reality, this is 9 times x minus 4 squared. So when I list my transformations, the first transformation is going to be a horizontal shift. Right 4. And then my second transformation will be a vertical stretch, because there is no reflection and there is no vertical shift. Vertical stretch 9 units. So this means I'm going to go x plus 4, and this means I'm going to go 9 times y. So when I make my chart, I have x plus 4, and I have 9 times y. So I have 2, 4, and then 2, 36. I have 3, 1, and 3, 9. I have 4, 0, and then still 4, 0. I have 6, 4, and then 9 times 4 is 36. And then I have 5, 1, 5, 9. So I'm going to make this next graph a little bigger. So I have So I have 4, 0 right here. So I have 236 up here. And I have 3, 9 down here. And then I have, gotta move those over a little bit. Then I have 5, 9 here, and 6, 36 up there. And that would be my parabola. If you have graph paper, you can space it a little better. I just didn't want to use this small graph. All right, so I know it was a long video today, and a lot of good information. So if you have any questions, please feel free to see me, and I will hopefully see you in class. Have a good rest of your evening.